Now we are going to discuss the topic direction cosine. Direction angles and direction ratio of a vector. We know that vector I, that is unit vector along x-axis, vector j, unit vector along y-axis, and unit vector k, unit vector along z-axis, are unit vector in RQ plane in the positive direction of x-axis, y-axis and z-axis respectively. This gives the direction of x-axis, y-axis and z-axis. As we know that unit vectors are meant for given the direction of any plane or any axis. If vector x with component x1, x2 and x3 is a non-zero vector of R cube, that means at least one component of x is non-zero and makes angle of measure alpha, beta, gamma with positive direction of x, y and z axis respectively. That means alpha is the angle between x-axis direction and vector x, beta is the angle between y-axis and vector x, and gamma is the angle between z-axis and vector x. Then alpha, beta, gamma are called direction angles of vector x, and cos alpha, cos beta, cos gamma are called direction cosines of vector x, as alpha is the measure of angle between vector x and unit vector I. We get by definition of angle between two vectors, cos alpha is equal to dot product of vector x and vector I and magnitude of vector x over magnitude of vector I. So we will calculate the dot product of vector x, whose component are x1, x2, x3 dot vector I, whose component are 1, 0, 0 over magnitude of vector x, that is x1 square plus x2 square plus x3 square into 1 square plus 0 square plus 0 square. So we get cos alpha is equal to x1 into 1 is 1 plus x2 into 0 is 0, x3 into 0 is 0 over under root x1 square plus x2 square plus x3 square. That is vector x1 over under root x1 square, x2 square, x3 square. Now, if our beta is the angle between y-axis and vector x, then cos beta is equal to x2 over under root x1 square, x2 square, x3 square, and cos gamma is equal to x3 over under root x1 square, x2 square, x3 square. Now as we get cos alpha, cos beta, cos gamma, now if we take or if we consider L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma, then L, M, N is equal to cos alpha, cos beta, cos gamma. That is vector x1 over under root x1 square, x2 square, x3 square, comma x2 over x1 square, x2 square, x3 square, comma x3 over x1 square, x2 square, x3 square. So we can rewrite it as that is L, M, N is equal to x1 over magnitude vector x, x2 over magnitude vector x, x3 over magnitude vector x. Or we can say that as magnitude is a constant, so we take it outside as a common factor and we get x1, x2, x3. That represents vector x. So it becomes vector x over magnitude x. That is a unit vector x. So LMN gives the direction of unit vector x. Also, if we take square and then add these direction angles, we get cos square alpha plus cos square beta plus cos square gamma. That is x1 square over under root x1 square, x2 square, x3 square whole square plus x2 square over under root x1 square, x2 square, x3 square whole square plus x3 square over under root x1 square, x2 square, x3 square whole square. So we get x1 square plus x2 square by taking the LCM. That will be x1 square, x2 square, x square, because square and 2 will be cancelled out. So we get which is equal to 1. So we get L square plus M square plus N square is equal to 1, and cos alpha, cos beta, cos gamma is equal to unit vector x. Therefore, cos alpha, cos beta, cos gamma is a unit vector in the direction of vector x, as vector x is unit vector, that is this, which is equal to k time vector x, where k is equal to 1 over modulus x, that is a positive quantity. Thus, if vector x is equal to x1, x2, x3 and vector x is non-zero and m is not equal to 0, let m times x is equal to mx1, mx2, mx3. Then the component of m vector x, namely mx1, mx2, mx3 are called direction ratios or direction numbers of vector x. So from here we get cos alpha is the angle between vector x and the x-axis and gives the direction component of or direction number of vector x in the x direction. Cos beta gives the direction number of vector x in y direction and cos gamma gives the direction number of vector x in the z direction. So this was all about the direction cosine and direction angle of a vector. Now we will discuss some problems which are based on direction cosine and direction angle of a vector. So the problem is here, find direction, cosine and direction angles of vector under root 2i minus j plus k. Now we have here vector x as, let vector x is equal to under root 2i minus j plus k can be written as under root 2 minus 1, 1. So to find its direction angles and direction ratio, we have to find its magnitude. Magnitude has special role to find out direction cosine or direction ratio. So it is component of vector I square plus component of vector j square plus component of vector k square. So we get 2 plus 1 plus 1, that is under root 4. As magnitude is positive, so we will take positive 2. Now let alpha, beta, gamma are the direction angles of vector x. Then, as we know, cos alpha is equal to x1 component over magnitude x. x1 component is under root 2 over 2 gives under root 1 over under root 2. Now, if beta is the angle between y-axis and vector x, then beta is equal to x2 component over magnitude x. So its component is minus 1 over magnitude, that is 2. Now cos gamma is equal to x3 over magnitude vector x. So we get x3 magnitude is 1 over 2. So that is our cos alpha, cos beta and cos gamma. Now as cos alpha is equal to 1 over under 2, that implies alpha is equal to pi by 4. Now cos beta is equal to minus half, as value of angle should be lying between 0 to pi, so it becomes pi minus cos inverse half. So it becomes pi minus pi by 3, that is 2 pi by 3, as we know the rules of inverse trigonometric function. Now, cos gamma is equal to half, that is the value of gamma is equal to pi by 3. Therefore, direction cosines are 1 over under root 2 minus 1 by 2 and 1 by 2, and directions angles are pi by 4, 2 pi by 3 and pi by 3. So this was the direction angle and direction cosine of a vector. Now the next problem is, if a vector x makes angle with measure pi by 3, 2 pi by 3 with x-axis and y-axis respectively, then find the measure of the angle made by vector x with z-axis. Now here we have two cosine angle, that is cos alpha and cos beta. Now we have to find cos gamma, that is the angle between vector x and z-axis. As we are familiar with the property L square m square plus n square is equal to 1. So let gamma be the angle between vector x and z-axis, and alpha and beta are the angles between vector x and y-axis respectively, and these are given angles. Angle alpha is, that is pi by 3, and angle beta is 2 pi by 3. As we know that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So, cos square pi by 3 plus cos square 2 pi by 3 plus cos square gamma is equal to 1. Cos pi by 3 is 1 by 2 whole square. Cos 2 pi by 3 can be find out pi minus pi by 3 plus cos square gamma is equal to 1. So that implies (1 by 4) cos pi minus theta is minus cos theta, but here is square, so it becomes cos square pi by 3 plus cos square gamma is equal to 1. So we get 1 by 4 plus 1 by 4 plus cos square gamma is equal to 1. That implies 2 by 4 plus cos square gamma is equal to 1. That implies cos square gamma is equal to 1 minus half, that is half. Therefore, cos gamma is equal to plus minus 1 over under root 2. That is, if cos gamma is equal to 1 by under root 2, that implies gamma is equal to pi by 4. That is, z-axis makes angle pi by 4 with the positive direction of vector x. And if cos gamma is equal to minus 1 by root 2, that gives gamma is equal to pi minus cos inverse 1 by root 2, that is pi minus pi by 4. that is 3 pi by 4. That is the angle made by z positive direction of z-axis with the vector x. So these are the two angles which the z-axis makes with the vector x. So these are the problems which are based on direction cosine, direction angle of a vector.